Hello everyone. In this video we will see about divisibilities of all numbers, not specific numbers only 2, 3, 5, 7, 11. Not only these numbers, we will see for all numbers, not necessarily one digit number, two digit numbers, even larger and larger numbers. How to create divisibility for that, we will see that. So in the beginning we will start from basic part, that is 2, 3, 5, 7, 11, and we will do that part in very few time, just 2 or 3 minutes possibly. So what is the divisibility of 2? If the number is even, then the number is divisible by 2. What is divisibility of 3? Divisibility of 3 is if sum of digits is divisible by 3, then the number is divisible by 3. Okay, and just like 2, divisibility of 4 is also same, that for 2 we are taking last one digit, for 2 we are taking last one digit only. For number 4 we will check last two digits we will check units place and tens place. If the number created by last two digits is divisible by 4, then the number will be divisible by 4. Same for 8 also, we will check last 3 digits. For 8 we will check last 3 digits. If the number created by last 3 digits is divisible by 8, then the number will be divisible by 8. Suppose the number is 435215112, and I have to check whether this number is divisible by which of these numbers, 2, 3, 4, 8. Then what I will do, I will take the last digit. If it is even, then it is divisible by 2. I will take now last two digits. It is 12. Number created by last two digits is 12, and 12 is divisible by 4. So the number is also divisible by 4. Whole number is divisible by 4. Let's check last three digits now. 512. Whether 512 is divisible by 8. For 8 we are taking last three digits. So if 512 is divisible by 8, then the whole number will be divisible by 8. So let's divide 512 by 8. Then you will get 8 6 are 48. Remainder will be 3, and then 8 4 are 32. So it is divisible by 8 also. So whole number is divisible by 8, and we will check for 3 now, whether it is divisible by 3. How we will check? The sum of digits. 4 plus 3 7 plus 5 12 plus 2 14 plus 1 15 plus 5 20 plus 1 21 plus 2 23. So here addition is 23. If this addition is divisible by 3, then whole number will be divisible by 3. But here it is 21. And not 21, it is 23. 23 is not divisible by 3, so this number is not divisible by 3, not by 3. Let's check for 5. What is the divisibility of 5? If the last digit is 0 or 5, then the number will be divisible by 5. Let's say for 25, the divisibility of 25. I want to check the divisibility of 25. Just like 5, we are checking last one digit. For 25, we will check last two digits. It should be either 25 or 50 or 75 or 00. If last two digits are any from this, that is 25, 50, 75, 00, then the number will be divisible by 25. We can create for any large numbers which are in the power of 5. Just like for 125, we can say if last three digits are 125 or 250 or 375 or 500 or 625 or 750 or 875 or 000, then the number will be divisible by 125. So out of all these 8 possibilities, if any in any group of 3 digits is there in the end, that is hundreds place, tens place, then the number will be divisible by 125. Now let's see for 7. For 7, there are actually two ways. I am explaining here one only. For now, I will explain the other afterwards. Suppose the number is 735213257193192, a large number. Then what we will do? We will divide this number in group of threes. So just like this, we read the number in international system. In same way, we will divide in group of threes. So we will add now alternate groups. So this is first group, this is third group, this is fifth group. These groups we will add. So addition of all these three groups will be, let's see what it will be. 735 plus 257 will be 992. 992 plus 192 will be, let's see, 992 plus 192 will be 1184. So it is addition of alternate groups. Now let's make the addition of remaining groups, that is 213 and 193. So this addition will be, it will be 406. It will be 406. If I am correct, it will be 406. And then these are two additions. This is group of this is addition of three groups. This is addition of other groups. They are all alternate groups. Those addition we have did. Now we will take difference of these groups. 1184 minus 406, and the difference here is 772. If this difference is divisible by 7, then the whole number will be divisible by 7. Then the whole number will be divisible by 7. Now let's see now one thing. Let's see whether this number is divisible by 7 or not. No, 772 is not divisible by 7. So this whole large number of what it is, it will be 735 billion, if I am correct. Oh no, 735 trillion 213 billion 257 million 193,192. This number is not divisible by 7. Just because this 772, that is difference of addition of alternate groups, is not divisible by 7. It is same for 11 also, but here we are taking alternate groups. For 11, we will take only alternate digits. Let's take same number 735213257193192. Now here we will take alternate digits. So here is 7 plus 5 12 plus 1 12 plus 1 13, 13 plus 2 15 plus 7 22, 22 plus 9 31, 31 plus 1 32, 32 plus 2 34. So here addition of first alternate group is 34. Then addition of remaining numbers. 3 plus 2 5 plus 3 8 plus 5 8 plus 5 13 plus 1 14 plus 3 17 plus 9 17 plus 9 is 26. And now we will again take difference of these two additions. 34 minus 26, it is here 8. Now if this difference is multiple of 11, then the number will be divisible by 11. But here 8 is not divisible by 11, it is not multiple of 11. So this number is not multiple of 11. Okay, multiple of 11 here and multiple of 7 here also includes 0. So suppose difference is 0, then also it will be divisible by that number. Okay, now this is all about prime numbers. Now think for composite numbers. How we can get divisibility of composite numbers? Let's see this number, easy one, 6. The number 6. The number 6 we can write as 2 into 3 as prime factorization. Remember, it should be prime factorization only. 6 is 2 into 3. Now we will check for divisibility of 2 and also divisibility of 3. If the number is divisible by 2 also and 3 also, then number will be divisible by 6. Suppose this is the number 31256 and I have to check whether this number is divisible by 6 or not. Then I will check for first 2. If number is even, then it is divisible by 2 and it is actually even, so it is divisible by 2. Let's see for 3 now. 3 plus 1 4, 4 plus 2 6 plus 5 11 plus 6 7, 17. 17 is not divisible by 3, so the number is not divisible by 3. We need both to be divisible. It is divisible by 2 also and 3 also, not any one. Here it is divisible by only 2 and not by 3, so the number is not divisible by 6. If by both numbers, if it is divisible, then the number will be divisible by 6. Let's take some other example. Let's take number 68. If I want to create the divisibility of 68, then what I will do? I will make prime factorization of this number. I will make prime factorization and I can write this as 17 into 4. But 4 is not prime, so I can write instead 2 square. 17 into 2 square. Now I will check the divisibility of 2 square, that is 4. We know what is the divisibility of 2 square. We have to check for last 2 digits. And then I will check the divisibility of 17. Now what is the divisibility of 17? Till now we don't know that, but we will check that afterwards. If you know what is the divisibility of 17, then apply that. Apply the divisibility of 4 also. Then you will get the divisibility of 64. If both 17 and 2 square are divisible by these numbers, the number is divisible, then the number will be divisible by 68. Suppose the number is, let's say, 132. Then I can write 132 as 11 into 2 square into 3. That is 11 into 4 into 3, that is 11 into 12, that is 132. So here I want to check for divisibility of 11 also, divisibility of 4 also, and divisibility of 3 also. If all of these 3 are satisfied, then the number will be divisible by 132. Like this we can create divisibility of any composite number. Now here is question, what for other prime numbers? What for other prime numbers? Suppose the number is 17, let's say. We need here 17, so let's take divisibility of 17. How I can get the divisibility of 17? Now here is only one method. By this one method, we can create divisibility of any number ending with 1, 3, oh not 5, 1, 3, 7 and 9. 1, 3 and 7 and 9. If the number is ending with 1, 3, 7, 9, and obviously the other numbers ending with 0, 2, 4, 5, 6, 8 are not prime numbers, and we are checking for prime numbers only. All prime numbers except 2 will always end with 1, 3, 7, 9. So for all prime numbers this trick will work. So what we have to do? If we are checking for divisibility of 17, we want to create the divisibility of 17. Then we will check the multiple of 17. I am writing here first step. Check for next multiple. Check for multiple which ends with 1 or 9. Okay, now there is question. There are also multiples of 17 which are ending with 1, and there are also multiples of 17 only which are ending with 9. So what should we take? We have to take that multiple which is nearest to 17. So let's write down here table of 17 on the 17, 17 2s are 34, 17 3s are 51. Oh, here is 51, the number ending with 1. Now, here is the second step. If the number is ending with 1, if that multiple is ending with 1, we have to subtract. We have to subtract. What should subtract and what to add, that we will see afterwards. But remember, when the multiple is ending with 1, we have to subtract, and if the number is ending with 9, then we have to add. What to add, what to subtract, that we will see now. Okay, so I want to create the divisibility of 17 and its nearest multiple is 51. I want to check whether this number 9357192 is divisible by 17 or not. So what I will do, I will first check which multiple is it. It is 51. This number is important. It is ending with 1, so we will subtract something. What to subtract, let's see. Okay, so this is 5. This digit we have to see, not digit, the previous number, because sometimes it can be 3-digit number. So we have to just take last digit of it, remove the last digit, unit place, and take the remaining number. So here it is only 5. So 5 times the last digit, that we will do, and we will again subtract it from remaining number. Take the last digit, multiply it with this digit or this number, then subtract it from the remaining number. So here 2 into 5 is 10. So after subtraction we will get the result something like this. Again, we don't know whether this number is divisible by 17 or not. So again we will repeat the process until we know that the number is divisible by 17 or not. So let's take this 9 now and multiply it with this 5. 9 into 5 is 45. Subtract it from remaining number. So it will give you number like this, 93,525. Again, I don't know whether this number 93,525 is divisible by 17 or not. So again I will take last digit, multiply it with this 5. So 5 into 5 is 25. Subtract it from remaining number, and then we will get answer as 9,327. Again, I don't know whether this number is divisible by 17 or not. So again I will take the last digit, multiply it by 5 and subtract from remaining number. We will repeat this process till we get confirmed that number is divisible by 17 or not. So 7 into 5 is 35. So we will get here subtraction as 897. Again I don't know whether this number is divisible by 17 or not. So again I will take last digit, that is 7, and multiply it with this 5. 7 5s are 35. Subtract it from remaining number, and this subtraction is now only 54. Now if 54 is divisible by 17, now this number, this difference is divisible by 17, then the number is divisible by 17. If it is not divisible, then the number is not divisible by 17. And here 54 is not divisible by 17, we know, because after 51 the next multiple of 17 is 68, not 54. So the number is not divisible by 17. This number, or this large number, is not divisible by 17. Okay, now let's create divisibility of other number. Let's take number 53. We want to create divisibility of 53. Now for 53, we will check its table and we will check whether 1 is coming first in the unit place or 9 is coming. So 53, 1 is 53, 53 2 is 106, 53 3 is 159. Now here it came 9. Okay, then what we will do? We will just take a number. For example, let's take, I want to check for this number whether the number is divisible by 53 or not. So I will take the last digit and multiply it with the remaining part after removing the unit place from this number, that is 15. So 15 into 4 will be 60 and subtract it from remaining number. So I will get here 1501. Oh, no, 1599 I will get. Okay, then the other part is the next part. I don't know whether this number is divisible or not. So again I will take the last digit, multiply it with 15. So 15 into 9 will be, 15 into 9 is 135. So subtract it from remaining number 135 and let's see whether this subtraction is divisible by 53 or not. So the subtraction is coming 24 and it is not even in table of 53. So we can say that this number 16,594 is not divisible by 53. Now you can create divisibility of any number. You can create for any number. Let's check for 7. I told that there is one more divisibility for 7. What we have seen previously, suppose this is the large number 1925213521312. Then what we will do? We will make group of 3 digits and add the alternate digits. Add the alternate groups. Add the alternate groups and take the difference of their addition. If that difference is divisible by 7, then the number will be divisible by 7. But here is one more way. You can see 7 is the number ending with one of these numbers, 1379. Actually it is 7 only. So we can use that trick here also. Check for the multiple of 7. It is 21, which is ending with 1. We have to check for such multiple which is closer to 7 and ending with 1 or 9. So here 21 is ending with 1. It is 1, so we will add. It is 1, so we will add. Oh, I think here we did the mistake. Yes. I will correct that now only. Suppose the number is 16,594. Then we are not subtracting here, we are adding here because the number is ending with 9. So 4 into 15 is 60. We will add here. This is the incorrect way. Sorry for that. But let's understand what it is. So after addition, it will become 1719. Again, we will take the last digit, multiply it with 15. So 15 into 9 will be 135. And after the addition, we will check whether it is divisible by 53 or not. So the addition here will be 306. Let's check whether 306 is divisible by 53 or not. We can check that easily. Say 53 5 is 265 and 53 6 is 318. So 306 is not divisible by 53. So the number is not divisible by 53. So this thing we have to take care. I did here one mistake, that when it is ending with 9, I have subtracted, but we have to add when number is ending with 9. Okay, so here it is ending with 1. So what we will do, we will take any number. For example, let's take 1 4 5 2 3. This method is easy for very large number, and this method is easy for small numbers like 6 to 7 digits maximum. At that part we will use this method. So what we have to do, we will take last digit, remove last digit from this part and take the remaining part, that is 2. So that 2 into this 3 is 6, and now we have to subtract because this 21 is ending with 1. So subtract, so it will be 1448. Then again take the last digit, multiply it with 2. 8 into 4 is 16. Subtract from remaining number. So it will be 112. 28, 128, and then again take the last digit, multiply it by 2, but it will give us 16 and answer will go in negative. So instead of that we will check whether 128 is divisible by 7 or not, and we can do it very easily. That divide 128 by 7, 7 1 the 7, 7 1 the 7, remainder is 5, and 7 8 the 56, remainder is 2. So remainder here is 2, which means number is not divisible by 7. In this way also we can check for divisibility of 7. So there are two ways for 7. I hope you understood how we did this and how to create divisibility of any number. I am showing you final one part only, one part. Let's check divisibility of some large number. Let's take 3-digit number now for last time. Let's take number 353. I don't know whether it is prime or not. If it is prime, then also it will work. If it is not prime, then also it will work. So 353, we are checking for divisibility of 353. Whether this large number is divisible by 353 or not. So what we will do, we will write down the table of 353 till we get the unit place as 1 or 9. So 353 2s will be 706, 353 3s will be 1059. Okay, it is ending with 9. So we can say that we have to multiply this number to the last digit, and we have to add that part because the number is ending with 9. So this 4 into 105 will be 420. Now we will add this 976591. Again take last digit, multiply it by 101, so it will give you 945. Again we will add that to the remaining number. Then 7 plus 5 12, here it will be 11, here it will be 15, and this will be addition. I am not sure till now whether this number is divisible by 100 and what was that number? For what we are checking 353. I am not sure whether this number is divisible by 353 or not. So I will repeat the process again. 2 into 105 is 210. So I will again add this, and the addition will be 2261. 2261. Now if you repeat the process again, it will give you number less than 353 and it will not be useful. So we have to check whether this number is divisible by 2261 or not. So let's complete here the table of 353 till we come to know whether this is divisible by 353 or not. So this is 3 4 will be, it will be 2 here, 4 3 12, carry over 2, it will be 1, not 2, carry over 1, and 4 20, carry over 2, 4 12, it will be 1412, and like this you can continue multiplication and creating table. So it will give you the next number as 1765. The next number will be, I guess, 2100, 2118, 2118, and then next number will be something around 2471. So the number, the difference is between these two parts. So it is not divisible by 353. 353 6 are 2118, 7 are 2471. So number 2261 is not divisible by 353. So we can say that this large number is also not divisible by 353. Okay, now one question. what are the proofs whether this thing is correct. For the proofs I will give the another video, because I don't want to mix the understanding of divisibility and the proofs of that. So for proofs I will make the separate video. Till that, bye bye. And if you like the explanation, you can subscribe the channel, like the video, and share this video so that many people can get this part. Thank you everyone.